Hello class, welcome to this lesson on solving radical equations, the fourth lesson in the unit. So this lesson is all about solving equations that include radicals or rational exponents. So how do we go about doing this? The goal is to be able to solve these radical equations and identify any extraneous solutions. And the standard is given below to solve simple radical equations with one variable and give examples of how extraneous solutions may arise. So extraneous solution, we kind of talked about it in one of the lessons, but we're going to include it as a vocab term here as well. All right, so when solving radical equations, remember that the square root and the square operations are essentially opposite or inverse operations, which means that they cancel each other out. Similarly, remember that the cube root and the cube operation are also inverse operations. Similarly, the fourth root and the fourth power operation cancel each other out. So if I combine those two together, they essentially annihilate each other. So if I have, for example, the cube root of x plus 1 and it's raised to the third power, the cube operation and the cube root essentially annihilate each other and leaving you with the original just x plus 1. So the radical disappears. All right, so now what are the steps to solving? First step is to isolate the radical expression, so move it to one side of the equal sign so that it's all by itself. Then you want to cancel it out using the operations above. You may need to do this multiple times depending on the equation that you're dealing with. So for example, if you had the cube root of x plus 1 squared equals 5, well, now that the radical is by itself, so you can go ahead and use the cube operation to cancel that out. And then once you do that, you have x plus 1 squared equals 5 cubed. And then we got to do this step again because we got a squared here. The only way to get rid of that squared is to do the square root operation. So this is what I mean by you may have to do this multiple times. So now, once you do that, then you're able to solve for x because you get the inside all by itself. So you can use any like two-step equations or multi-step equations at that point. Then you check your solution by plugging into the original equation. The reason why we have to check our solution in this step is because just like when we solved rational equations, recall in Unit 4, we need to identify any extraneous solutions. Now these are solutions that don't make any sense when they're plugged into the original equation, but nevertheless we actually solved and got those solutions. So those are considered sort of like fake solutions. You know, we got the solutions by solving, however they're not really the true solutions. Alright, so we're going to go ahead and do a couple examples of how we solve radical equations, and then we're going to check for the extraneous solutions. So let's look at the first one. We have the square root of x plus 5 minus 1 equals 3. So remember, the first step is to isolate the radical. So you got to get this square root all by itself, which means that you got to get rid of the minus 1 here. So in order to get rid of the minus 1, I'm going to go ahead and add 1 to both sides. So we left with square root of x plus 5 equals 4. So now that we isolated the radical, we're going to go ahead and get rid of it. Now this is a square root, so remember that square root and square are inverse operations, so they cancel each other out. But if we do it on one side, remember to do it on the other side as well. So we just applied the square operation to both sides. Now we're going to go ahead and cancel out the square and the square root, and we get x plus 5 equals, and then 4 squared is 16. Now we're going to solve for x. Now that the radical is eliminated, we can solve it like normal. So we got here x equals 11. So then next we're going to check this solution to make sure that it works. So we're going to do a check here real quick. So we're going to plug it into the original equation here. So if we do that, we get square root of 11 plus 5 minus 1 equals 3. So notice here we get square root of 16 minus 1 equals 3. And then the square root of 16 is 4. 4 minus 1 is 3. So 3 equals 3. So that checks out. So now if it didn't match up, if the left and the right sides did not match up, then we know that we have an extraneous solution. So therefore we can go ahead and confidently say that x equals 11 is actually one of our solutions. All right. So let's look at the next problem here. We have a cube root and a squared operation on this side. Again, just like the last problem, we're going to isolate the radical, which means that we're going to get it by itself. So we got to get rid of this plus 2, so I'm going to subtract 2 on both sides here. So now we got the radical all by itself, so we got the cube root of x squared, and then 4 minus 2 is 2. Alright, so if we want to get rid of the cube root here, well, we're going to have to do the cube operation. So the cube operation is the opposite of that, and that gets rid of the cube root. So now we got x squared by itself equals 2 to the third power. Now we can go ahead and take the square root of both sides because we got an x squared here, right? So we're going to go ahead and take the square root of both sides. Now remember the rules. Remember that if we take the square root of both sides, we need to actually include the plus or minus version of that solution. So every time you're taking a square root or an even root, right? So like 4th root, 6th root on both sides of the equal sign, you're going to include the plus or minus sign there. So make sure that you have all the solutions. So we have here this squared and the square root cancel. So we have x equals plus or minus the square root of 2 to the third. And I'm going to leave it as 2 to the third because I can simplify that. I can actually simplify the 2 to the third into 2 squared and 2. The reason why I do that is because I want to simplify this radical. So I'm going to go ahead and simplify this radical now. We get plus or minus the square root of 2 squared times the square root of 2 to the first power. So now again, these are opposites, so they cancel. And this one cannot cancel because it's not squared or anything like that. It's just a 1 power. It's just invisible 1 power. So we have here plus or minus 2 times the square root of 2, and this is like the simple case. So we got 2 solutions here. We're going to actually check those real quick. So again, check by plugging those into the original equation. So we have here the cube root of x squared, and x is going to be both of these guys. So we have that squared plus 2 equals 4. So now we're going to go ahead and subtract 2 on both, or I'm sorry, we're not solving here, we're checking our solution. So now we're going to go ahead and actually square this out. So 2 squared is 4, and then the square root of 2 squared is 2. But I'll go ahead and show my work here. So I got the cube root of, I'm going to distribute that power, so I get 2 squared, and then I got square root of 2 squared, because I'm distributing the power to both of those. The square root of 2 squared, this cancels, leaving you with 2, and then 2 squared is 4. So I have here the cube root of 4 times 2 plus 2 equals 4. So then the cube root of 8 plus 2 equals 4. The cube root of 8 is 2, so we get 2 plus 2 equals 4. So 4 equals 4. This checks out. So therefore we can go ahead and confidently say that these two are our solutions. Notice that I plugged in only the positive version, but if I plugged in the negative version, I would also get the same answer. So I'm going to go ahead and box my solutions. I got 2 solutions here. Alright, pause the video, try the following 2 problems first. All right, so let's try the first problem here. So we want to solve the radical equations, again, checking for extraneous solutions. So again, we want to isolate the radical, so we want to get the plus 3 out, out of the way. So we're going to subtract 3 on both sides. So we have the square root of x minus 2 equals 2. So now we're going to get rid of the square root by doing the square operation on both sides. So now the square and the square root cancel. So we have x minus 2 equals 2 to the second, which is 4. Now we're going to go ahead and add 2 to both sides of the equal sign. We have x equals 6. Now we're going to check the solution real quick. So if we plug in 6, again into x, we get the square root of 6 minus 2 plus 3 equals 5. So now we know the square root of 6 minus 2 is 4. The square root of 4 is 2, so we get 2 plus 3 is 5. So 5 equals 5. This checks out. We can box this as our final solution. All right, let's go ahead and check the next problem. So we have the cube root of x minus 1 squared plus 2. So right now the radical is already isolated, so we don't have to do that step. Now let's just say, for example, that I did have a 2 here. If I had a 2 on the outside, then what I would have to do is I would have to divide 2 on both sides to get rid of that 2, and that would isolate my radical. However, we don't have to do that here because we don't have a 2 there, but if we did have a number there, you would divide that off before doing anything else. Okay, so I just wanted to give you another alternate example. So here we cannot eliminate, or we cannot isolate because it's already isolated. So we're going to go ahead and continue. We got to get rid of the cube root by doing the cube operation on both sides. So now that cancels, the radical cancels, and then the cube root. So the radical and the cube root are like together as one symbol. So we have x minus 1 squared equals 2 to the third. So now we have to get rid of the squared, so we're going to do the square root of both sides. So remember, when we do the square root of both sides, we need to include the plus or minus version. So I'm going to go ahead and give myself some room here. I'm going to do the square root, and I'm going to include the plus or minus version. All right. So now the square root and the square cancel, leaving me with x minus 1 equals plus or minus square root of, in this case, 2 to the third. We'll leave it as 2 to the third. And now we're going to go ahead and add 1 to both sides to solve for x. So we get x equals plus or minus the cube, or the square root of 2 to the third plus 1. Now the reason why I don't do anything to the 2 to the third is because I'm going to simplify it. I'm going to break it down. I'm going to break down the square root of 2 to the third as the square root of 2 squared and the square root of 2 to the first power. And then these cancel. All right, let me go ahead and rewrite the other problem here real quick. Okay, so then these cancel, leaving me with 2 and then square root of 2. So basically this becomes 2 square root of 2. So I'm going to go ahead and plug that in here. So x is equal to plus or minus 2 radical 2 plus 1. So that is my solution, if you will. Now we're going to go ahead and check this, of course. So let's check our work. Now, when I check the work, I could plug this in or I could plug this in. But what I'm going to do is I'm going to plug this in. I'm going to actually plug this in to the original equation because it's simpler to actually plug that in than it is to do the 2 radical 2. So I'll show you what I mean by that. So our original equation is the cube root of x minus 1 squared. So now I'm going to plug in this. So if I do that, I get the cube or the square root of 2 cubed plus 1. I need a little bit more room here. And then this is x, right? That's x. And then x minus 1 squared. So remember the equation was cube root of x minus 1 squared and then equals 2. Okay, so now we have the plus 1 here and the minus 1 here cancel, and now have the cube root of the square root of 2 cubed. And then this is going to be squared. So notice that this square cancels out with the square root here, and this cube cancels out with the cube root here. So that leaves me with 2. So I get 2 is equal to 2. Now, of course, you didn't have to do this. You could have plugged in this as a decimal on the calculator, and then you would have gotten the same answer. But I was just showing you the exact way of doing this without having to use a calculator. So this does end up working out. So we have no extraneous solutions. So therefore, this is our final solution. All right, so now we're going to solve radical equations, this time with a variable on either side. So notice that we have a variable here rather than just a number. So how do we solve equations with a radical as well as a variable that does not have the radical? So if we want to solve this equation, again, we have to follow the same procedure. We want to isolate the radical on one side. So in this case, we isolated the radical. There's nothing that we can do here. The square root is all by itself. So now next you're going to eliminate that radical. So you're going to square both sides. The opposite of square rooting is squaring. So the square and the square root operations cancel, leaving you with the inside. 3x minus 2 equals x minus 4 squared. I'm going to write x minus 4 squared now as x minus 4 times x minus 4 because I'm going to go ahead and FOIL that. So we're going to have to go ahead and we're going to have to FOIL that. So now we're going to do first, outer, inner, last. So first, x times x is x squared. Outer, negative 4 times x is negative 4x. Inner, negative 4 times x is negative 4x. And last, negative 4 times negative 4 is positive 16. Going to go ahead and bring down the left side because we're not doing anything there. Now we got a quadratic equation that we got to solve here, so this is more interesting as far as solving. So we're going to go ahead and combine these two. This is going to be a negative 8x there. So we have x squared minus 8x plus 16. 3x minus 2 on the left side. So now, since it's quadratic there because of that square, then we're going to have to move everything to one side and get 0 on the other side, okay? So we're going to move all of this over to the right-hand side here. So I'm going to get rid of the 3x by subtracting it. I'm going to get rid of the negative 2 by adding it. So this cancels, so I get 0 on the one side, which is exactly what I want. And then I have x squared minus 11x plus 18. Now I can solve this because it's a quadratic equation. I can factor it, use any methods that are possible. So in this case, I'm going to go ahead and do an x table. 18 on the top, negative 11 on the bottom. You guys notice that we generally don't get away from solving these quadratics, which is why we do this in the beginning of the course, because you're constantly having to do problems like this. So you need two numbers that multiply to 18 but add up to negative 11. In that case, that would be negative 9 and negative 2. So we're going to go ahead and factor this using those two numbers, minus 9 and minus 2. Then use the ZPP, the zero product property. We set both of those equal to 0 and solve. In this case, this will be plus 9 on both sides. This will be plus 2 on both sides. And we get our two possible solutions, 9 and 2. I say possible solutions because we need to check to see if they make sense, to see if there's any extraneous solutions. So we're going to go ahead and check that. So if we plug in 9 into the original, let's check 9 first. Plug this into this. So square root of 3x minus 2 equals x minus 4. So let's do x equals 9 first. So the square root of 3x minus 2, that's what the equation said, 3x minus 2 equals x minus 4. And then x is 9. So x is 9 minus 4. So we're going to check that, see if it works out. So at the square root of 27 minus 2 equals 5, 9 minus 4. Then the square root of 25 equals 5, which seems to match up. So far we have a solution, x equals 9. We're going to check to see if x equals 2 is also a solution as well. So you have x equals 2. We got the square root of 3x minus 2 equals x minus 4. So we have square root of 6 minus 2 equals negative 2. We get the square root of 4 equals negative 2, or 2 equals negative 2. Now this is not true, right? So this is not a solution. So we have an extraneous solution. So x equals 2 is an extraneous solution. So now you know why we check our solutions. So that means it's not an actual solution, it's just extraneous. So we're going to cross that out, that's not a solution. So this right here, boxed, is my final solution. If both of them do not work when you actually plug in, then you would have no solution. So if all of them are extraneous, this means by default you have no actual solutions. Pause the video and try the following two problems out first. Alright, so let's take a look at the first problem. We got a radical with a non-radical variable on either side. Notice that the radical is already isolated, so I'm going to go ahead and just get rid of it right away. So I'm going to actually square both sides here to get rid of that. So squaring and square root are the opposite operations. So this cancels with the radical, leaving me with the inside 7x plus 8 equals x squared. Now this is quadratic because we got that squared, so we're going to move everything to one side and make the one side 0. I want to move everything to the left side, so I'm going to go ahead and just subtract the 7x as well as subtract the 8. Okay, so I'm going to do that on both sides. So I'm going to subtract 7x and then I'm going to subtract 8 on both sides. So again, there are no like terms on this left side, so I'm just going to rewrite it from highest to lowest power. So x squared goes first, minus 7x goes second, and then minus 8 goes last, equals 0 on the right side. So now this is quadratic, I should be able to factor this. So let's go ahead and factor this. Negative 8 on the top, and the b term, the negative 7 on the bottom. So I have to multiply negative 8 but add up to negative 7. So in that case that would be negative 8 and positive 1. So I'm going to break this down into my double parentheses. I'm going to factor it. X minus 8 using those two numbers, x plus 1. Now I'm going to use the ZPP, the zero product property. I'm going to set both of those equal to 0. Go ahead and add 8 on both sides here and subtract on 1 on both sides for the other equation. So we got two potential solutions here. Of course, we are going to check our solutions here. So let's plug in, let's check with x equals 8 first. So we have x equals square root of 7x plus 8. So x equals square root of 7x plus, what was it, 8? Yeah. All right, so let's go ahead and check this out. So we get 8 equals square root of 56 plus 8. 8 equals square root of 64. 8 is equal to 8, so this checks out. So far we have that as a solution. Let's check the -1. They may both be the solution. There need not be an extraneous solution, so they could potentially both be a solution, but we need to check. So we have x equals the square root 7x plus 8. So -1 equals square root -7 plus 8. -1 equals square root of 1. -1 is equal to 1, which is not true. So therefore, this is an extraneous solution. Which means that this is not a solution. All right, let's look at the next problem. We got a radical and it's already isolated, so there's no need to do anything to it. So let's go ahead as far as isolating it. So next we're going to go ahead and get rid of the radical. We're going to square both sides to get rid of the square root. So we have x plus 2 on the right hand side equals x plus 2 squared. So I'm going to write that as x plus 2 times x plus 2 because I'm going to FOIL that. First, outer. So first, x times x is x squared. X times 2 is 2x. 2 times x is 2x. And lastly, 2 times 2 is 4. So we kind of combine these two. X squared plus 4x plus 4 equals x plus 2. Now, since this is quadratic, I'm going to move everything to one side. So I'm going to subtract this x here, and I'm going to subtract this 2 here. That way, this right-hand side becomes 0. They cancel. So I got x squared plus 3x, 4x minus x, and then 4 minus 2 is positive 2. All right, I'm going to see if I can factor this. So I get a 2 on the top and a 3 on the bottom. I had to multiply to the top, add to the bottom. So that would be 2 and 1. So I can factor this now. X plus 2, x plus 1 equals 0. Then I use the zero product property. X plus 2 equals 0. X plus 1 equals 0. Subtract 2 on both sides. Subtract 1 on both sides for the other equation. X equals -2. X equals -1. So we're going to check our solutions here. So let's check x equals -2 first. So we're plugging it into the original. So the original was x plus 2 equals square root x plus 2. Pretty easy to remember. So x plus 2 equals square root x plus 2. All right, so -2 plus 2 is 0. 0 equals square root of 0, which is definitely true because the square root of 0 is 0. So this is true so far. We're doing good. So let's check -1. X plus 2 equals square root x plus 2. All right, so -1 plus 2 is 1 equals square root of 1. And that is true. 1 is equal to 1 because square root of 1 is 1. So this checks out. So we have here two solutions. We have no extraneous solutions at all. This is what I was saying earlier. Just because you have two or more solutions doesn't mean that one of them is extraneous. Both of them could be the solution. All right, so now the next topic here we're going to be solving equations with two radical expressions. So if we have two radical expressions or two radicals, what we're going to do is we're going to isolate one of the radicals to one side of the equal sign so that it's all by itself. Then we're going to square or cube, depending on the radical, both sides to cancel one of the radicals. Once you do that, you're going to isolate the other radical because one of the radicals will not cancel out when you do this, but the other one will. So now that one of them is canceled out, you can isolate the other radical to one side and then square or cube again to cancel that radical out. So it's sort of like a chaining effect. You're doing one and then you're doing the other one after that. Okay, so I'll give you a quick example of how that works. So let's say we had an easy, something like square root of x and then square root of x plus 1 equals 5, something like that. I'm just going to make something up. So we have two radicals here, so I'm going to go ahead and move one of the radicals to the other side. So let's say I decide to move the square root of x to that side. In that case, I guess square root of x plus 1 equals 5 minus square root of x. So I isolated one of the radicals. I did that step. I'm going to square both sides to get rid of that one of those radicals. So this cancels out. So that gets rid of that. Now this radical will not cancel out because we're squaring. We're actually foiling this, right? So I can write this out as a FOIL, which means it won't cancel out. So if I FOIL this, I get 25 minus 2 radical x plus x. I know I did that pretty quickly, but I'm just doing this to get the point across. You're still going to have a radical x there, and then you got to isolate that and then square both sides again. So this is what I mean by that. We're going to do this in more detail in the example that comes up, but I just wanted to illustrate that. So now we're gonna once we do that, we're gonna isolate this other radical again and then square or cancel to get rid of it again. Then we solve for x and then check for extraneous solutions. All right, so let's show you how to do this in an example. Again, the difference between this and the previous equation is that you're going to end up squaring twice or cubing twice because of the fact that you have two radicals. All right, so if we want to solve this equation, again, isolate the variable to one side. So I'm going to move this square root of 2x over to the other side. That way this radical is all by itself. So now we have this cancels. I get the square root of x plus 9 equals 3 plus the square root of 2x. Now I can go ahead and square both sides because I want to get rid of the squared here, the square root. But I got to do the same thing to the other side. So this square and square root cancel. Now I'm going to write this as a FOIL because that's what it is. It's two of them, right? So it's this times another one of those. Don't get confused and try to square both of them separately. This is a FOIL. So we're going to do first 3 times 3 is 9. Outer. 3 times square root of 2x is 3 square root of 2x. Inner. 3 times square root of 2x is another 3 square root of 2x. Last. Square root of 2x times square root of 2x is square root of 2x squared. And then the square and the square root cancel. So it's just going to be square root of 2x. Again, we're ignoring the absolute value for the purposes of this equation, okay? Because we're going to actually solve this out. So we're going to ignore that. So we got 9 plus 3 and 3 is 6. So we got 6 times the square root of 2x plus 2x. This is equal to x plus 9. All right, so now we have one radical left. So we're going to go ahead and isolate that radical, which means I'm going to move the 9 over and I'm going to move this 2x over. So let's go ahead and do that. Let's subtract this 9 over. Let's subtract this 2x over. That way we get that radical by itself. So we have x minus 2x is negative x. 9 minus 9 is 0, so that actually cancels, which is very nice. So we get negative x equals 6 times the square root of 2x. Again, this radical is not completely by itself because of that 6. So what I'm going to do is I'm going to go ahead and, this is multiplying, right? So I got to divide it off. So I'm going to divide by 6 on both sides to get rid of that. So let me write this on the right-hand side here. I got negative x over 6 equals square root of 2x. Now let's go ahead and get rid of the radical once and for all. Square root both sides, or square both sides. So we have, remember, a negative squared is a positive. So we have x squared. Don't forget to distribute here and here. So we got to do 6 squared. One of the exponent properties that we touched upon in the beginning of this unit. And then the square and the square root cancel, leaving you with 2x. Again, we're going to ignore the absolute value here because we want to just consider, we're going to actually check our solutions anyway. So we're just going to do like this. And then in this case, we have x squared over 36 equals 2x. Right, I'm going to get rid of that 36. I'm going to go ahead, because that 36 doesn't look very good, right? So I'm going to go ahead and multiply by 36 just to get rid of it, because I really don't want that fraction to be there. So get x squared equals 72x. All right, this is quadratic, so because of the squared. So let's go ahead and move the 72x to one side. Since it is quadratic, we want one side to be 0. So we get x squared minus 72x equals 0. So we can factor this, but not factor using the x table. We're going to factor this using, just by factoring out the greatest common factor. So what do they have in common? Well, they have an x in common, so I'm going to pull that out. So x times x is x squared. X times negative 72 is negative 72x. So this gets me back to the original. This is equal to 0. And then I can use the zero product property right away. So I say that this is equal to 0, and I say that x minus 72 is equal to 0, and then I'm going to solve this right-hand equation and get x equals 72. So we're going to go ahead and check our solutions here. All right, so let's go ahead and check. Let's do the x equals 0 first. So we're going to plug this into the original equation. The original equation is square root of x plus 9 minus square root of 2x equals 3. Okay, so we have square root of x plus 9 minus the square root of 2x equals 3. I believe that's what the equation was, but I'll double check that. Yep. All right, so we have the square root of 9 minus the square root of 0 equals 3. Square root of 9 is 3, square root of 0 is 0, so we get 3 equals 3. This checks out. All right, let's check out x equals 72. So we have the square root of x plus 9 minus the square root of 2x equals 3. So we have the square root of 81 minus the square root of 144 equals 3. The square root of 81 is 9. The square root of 144 is 12. So 9 minus 12 is negative 3, which is not equal to 3. So this is actually not a solution. This is extraneous. So our only solution is x equals 0. Go ahead and pause the video and try the following problem. Okay, so let's solve the first one here. We got a double radical, So we're going to have to, isolate one of the radicals. So let's move this square root of 3x over to the right-hand side by adding it. So this cancels because we got a negative and a positive there. We have the square root of x plus 4 equals, I'm going to write this out as square root of 3x minus 2. Since you can't combine those, you might as well just write them out next to each other like that. So now we're going to square root or square both sides to get rid of that square root. So this cancels. You get x plus 4 equals, now you can't cancel this out. It's tempting to cancel that out, but we can't do that because this is a FOIL. So I'm going to write this out so that I have two of them, like that. Okay, so let's do first square root of 3x times square root of 3x is the square root of 3x squared. And then which, these cancel out, leaving you with 3x. Again, ignoring the absolute value. Square root of 3x times negative 2 is negative 2 square root of 3x. And then inner, negative 2 times square root of 3x is another negative 2 square root of 3x. And then negative 2 times negative 2 is positive 4. Again, make sure to bring down the left-hand side and the equal sign. Alright, so we're going to combine these two together. So we have x plus 4 equals 3x minus 4 square root of 3x. Remember from the previous lesson, to combine those two radicals, you're just doing negative 2 and negative 2, which is negative 4, and you have that many of the 3x's. And then plus 4. Again, we have one radical here. We want to eliminate it, so let's move the 3x over to the left-hand side to move it, and let's move the 4 over to the other side as well. Again, the 4 cancels out, which is very nice. X minus 3x is negative 2x. So we get negative 2x equals negative 4 square root of 3x. This cancels out, of course. So now we're going to get rid of this negative 4 there by dividing it on both sides. So this here becomes negative 2 over negative 4 is going to be a half, so that becomes x over 2. There's an invisible 1 there, but I'm not going to write it there. Again, this being reduced to a half. And then this is equal to square root of 3x. So now the square root is finally by itself. I can go ahead and square both sides. So we get x, remember to distribute the squared to both. So you get x squared over 2 squared equals 3x. I'm going to go ahead and rewrite this. So I got x squared over 4 equals 3x. I'm going to go ahead and multiply the 4 on both sides just to get rid of that fraction. You get x squared equals 12x. Now this is quadratic, so I'm going to move this over to the side with the x squared so that I have 0 on one side. And I can't factor this using the x table because I only got 2 terms. So I'm going to go ahead and pull out what they have in common. They got an x in common. So x times x minus 12 equals 0. Again, distribute and you should get the original, which is exactly what we want. Then use the 0 product property. So you're going to set this equal to 0 and then set this equal to 0. And solve those separately. So x equals 0, x equals 12. Next we check. So let's check x equals 0 first. So the original equation is square root of x plus 4 minus square root of 3x equals negative 2. So square root of x plus 4, so square root of 0 plus 4 minus square root of 3x equals negative 2. And I go ahead and double check, make sure that everything's okay. All right. So now we got the square root of 4 minus the square root of 0 equals negative 2. Square root of 4 is 2. 2 minus 0 is definitely not negative 2. So we can say that this is extraneous. let's check out the next solution. The next solution is 12. So we get the square root of x plus 4 minus square root of 3x equals negative 2. So we got the square root of 16 minus square root of 36 equals negative 2. The square root of 16 is 4. Square root of 36 is 6. So this checks out. Negative 2 equals negative 2. So it looks like we have one solution only. So we're going to cross this out. This is our final solution. All right, so now let's talk about solving equations with a rational exponent, the last topic of this lesson. So if we want to cancel out a rational exponent, remember rational means fraction, right? So it's like a fractional exponent, like 1/2 or something like that. So to cancel out a rational exponent, remember that also rational exponents mean radicals. So if I'm talking about the square root of x, well, that's the same thing as x to the 1/2 power. Remember, power over index. So if I got a rational exponent, I can solve it just the way that I would solve a square root or a radical equation. But the way to do this is to simply raise both sides to the power of the reciprocal of the power that you have. So for example, if I want to get rid of this squared, this square root, I would square both sides, right? Well, similarly, if I want to get rid of this 1/2 power, I can raise it to the 2 power, or 2 over 1 power. 2 is the reciprocal of 1/2, right? And so in the same way that the square and the square root cancel, the 2 over 1 and the 1/2 cancel. So it gives me the same exact result, x, right? So it cancels out. I'll give you another example. So if I have the one on the bottom, there's an example on the bottom. So if I have here x to the 2/3 equals 5, I can raise both sides to the reciprocal of 2/3, 3 over 2 power. And then of course I got to do the same thing to the other side. But now that this is a reciprocal, 3 times 2 is 6, 3 times 2 is 6, and so I get 6 over 6, which is 1. So basically these cancel out, leaving you with 1. So that's how you cancel out a rational exponent. Now this other one, example, I can raise both sides to the 5 over 4 power, the flip of that, and so the 5's cancel, the 4's cancel, and everything cancels for the exponent on the left. So that's how I go about canceling out, rational exponents. So you can only do this once you isolate the expression with just a rational exponent. So for example, if I have something like this, I need to get this all by itself. So in order to get this all by itself, I need to subtract the 5. Then I get 2, and then I get all of this. Again, I want to isolate this, so I need to divide by 2 on both sides to get rid of that 2. And then I can get it by itself. So now it's by itself. That's what I mean by isolating it. And then now we can get rid of it by doing the reciprocal of that exponent. And then solve from there. So that's the idea for solving equations with rational exponents. So let's go ahead and look at a couple examples here. So if we wanted to solve this equation, right now, notice that this part is already isolated. It's in its own parentheses, and the entire thing is raised to that power. So we don't have to isolate it. What we're going to do is we're going to raise both sides to the reciprocal power, 2 over 5. And so now these cancel. I got to do the same thing to the other side, 2 over 5. So since they cancel, we get x squared plus 5x plus 5 equals, now we get 1 to the 2/5 power, which is just going to be, remember, 1 to the 2/5 power. This is the same thing. So 1 to the 2/5 is the same thing as, remember, power and then index, right? So 1 squared is just 1. What's the 5th root of 1? That's just going to be 1, because 1 times 1 times 1 times 1 5 times is 1. So this is just going to be 1. All right, so now this is quadratic, so I'm going to go ahead and subtract the 1 on both sides, and I get x squared plus 5x plus 4 equals 0. And I can go ahead and factor that using an x table, of course. We got 4 and 5, which is going to be 4 times 1 is 4, 4 plus 1 is 5. So we get x plus 4, x plus 1 equals 0. And using the ZPP, zero product property, x plus 4 equals 0, x plus 1 equals 0, subtract 4 on both sides, subtract 1 on both sides. So x equals negative 4, x equals negative 1. Then, of course, we check, right? So we check our solutions. So if I plug in negative 4 into the original, we get x squared plus 5x plus 5 raised to the 5 halves power, not 2/5, equals 1. All right, so if we plug that in, well, negative 4 squared is 16, so I get 16, and then I get minus 20 plus 5 raised to the 5 halves equals 1. So I get here negative 4 plus 5 raised to the 5 halves equals 1, and then I get 1 to the 5 halves equals 1, so 1 is equal to 1. So this checks out. Let's plug in negative 1 now. So I get x squared plus 5x plus 5 to the 5 halves equals 1. So I get here, with negative 1 squared is 1, 5 times negative 1 is negative 5. I get negative, let me double check the numbers here. Yeah, so I get negative 1 squared is 1, and then 1 minus 5 is negative 4, and then I get negative 4 plus 4. So negative 4 plus 4 is 0, and 0 to the 5 halves is 0. So 0 does not equal to 1, so this is extraneous. So therefore my only solution is x equals negative 4. We're going to go ahead and get rid of that negative 1, and that's our solution. All right, so that's how you deal with rational exponents. Let's look at one more here. So we have here a rational exponent on the left side. It's already isolated, so let's go ahead and get rid of it. Raise it to the 2/3 power. Do the same thing on the other side. This is, you can think of this as a, you can think of this 3 here as a 3 over 1. So we have this cancels, only the 3's cancel here, and then leaving you with 2. So we have x plus 18 equals x minus 2 raised to the 2nd power. You can also think of this as 3 times 2 is 6, and 1 times 3 is 3, which is 6 over 3, or 2. Same thing. So since this is squared, I'm going to go ahead and FOIL it, save some time here. X squared minus 2x plus 4, x squared, combine those two, minus 4x plus 4. Now this is quadratic, so I'm going to go ahead and move this x over here and move the 18 over there. So I get 0 equals x squared minus 5x minus 12. Then I'm going to factor that, negative 12 on top, negative 5 on the bottom, which is going to be negative, let's see, oh, oops, this should be 14 minus 18 is negative 14, not a negative 12. It should be a negative 14. So this is going to be negative 14, and it has to add it to negative 5, which would be negative 7 and positive 2. Apologize for that mistake there. So now we can factor, double parentheses, we get x minus 7, x plus 2, use the zero product property. So that'll be x equals 7, x equals negative 2. I'm not going to show that. It's just going to be plug it in. 7 minus 7 is 0. Let's go ahead and check our work here. So x equals 7. Plug it into the original. So x plus 18 to the 3 halves equals x minus 2 cubed. Okay, so x plus 18. So x plus 18 to the 3 halves equals x. Wait, I think it was x minus 2 to the third. So x minus 2 to the third, x minus 2 to the third. So we get 25 to the 3 halves equals 4 to the third. Or 7 minus 2 is 5. 5 to the third. All right, so 25 to the 3 halves power, that's the same thing as, remember, power and index, right? Power over index. Let me double check to make sure. Yeah, it was 3 over 2 power. And this is equal to 5 to the third. Well, what's the square root of 25? The square root of 25 is 5. So this becomes 5 to the third. And this is the same thing as 5 to the third. So we don't even have to go further. We know that it's true. So x equals 7 checks out. Now let's check out the other solution, negative 2. So we get the 7 plus, or I'm sorry, x plus 8 to the 3 halves, 18, equals x minus 2 to the third power. So you have negative 2 plus 18 is 16. So you have 16 to the 3 halves equals negative 4 to the third. So this is power over index, an invisible 2 there. So we got negative 4 to the third. Now the square root of 16 is 4, so this is 4 to the third equals negative 4 to the third, which those are not equal to each other because the right hand side will be negative, the left hand side will be positive. So this is extraneous. So the only solutions here, or solution, is this guy. All right, don't worry about that problem. Go ahead and try the first problem here in this set. All right, so let's look at this first problem. So we have here, we're going to go ahead and add 14 to both sides just to isolate that radical. We get all of this raised to the 3 halves equals positive 12. Positive, I need to make sure this is correct. It's 14 minus 6 is 8. There you go, so 8. So now we got to get rid of the 3 halves. So I'm going to raise both sides to the 2/3 power. So now these cancel. I get x squared minus 3x minus 6 equals 8 to the 2/3 power. 8 to the 2/3 power, that's just power and then index. So let's go ahead and do that off to the side. We know that this right here, the cube root of 8 is 2, and then 2 squared is 4. So this is going to be equal to 4. So now let's subtract 4 on both sides, because we got a quadratic. So now we can start our next table, negative 10 on top, negative 3 on the bottom. So that'd be negative 5 and positive 2. Go ahead and factor using those numbers. Using the zero product property, we get that x equals 5, x equals negative 2. We can go ahead and check our solutions. Let's do x equals 5 first. So we get x squared minus 3x minus 6. So x squared minus 3x minus 6 raised to the 3 halves minus 14 equals negative 6. Okay, so 5 squared is 25. So we get 25 minus 15 minus 6 to the 3 halves minus 14 equals negative 6. 25 minus 5 is 10. 10 minus 6 is 4. Now this is the same thing as square root of 4 cubed, right? So this right here, same thing as the square root of 4 to the third. Remember, it's power over index. I know that the square root of 4 is 2, and this is going to be 2 to the third, which is 8. So this will be 8 minus 14 equals negative 6, and indeed this is going to work out. So we're so far so good. Now let's check out x equals negative 2, and we'll do it over on this side. So we have x squared minus 3x minus 6 to the 3 halves minus 14 equals negative 6. So negative 2 squared is 4. Negative 3 times negative 2 is 6. Alright, 6 and 6 cancel, so this would be 4 to the 3 halves power, which we know that from earlier that that's equal to 8, right? So this is going to be 8 minus 14 equals negative 6, so this actually is going to check out as well. So we got no extraneous solutions, we got 2 solutions in total. Alright guys, that's it for the video. I know there's a lot of many topics here, but this is a sort of a big unit because there's a lot of different cases here involved with radical, double radical, and rational exponents. But I hope you learned something from this video, and I'll see you in the next one.